All right, we are live. I'm just going to make sure that the audio is working, and then we'll get started. There we go. Audio is good. So we're going to begin. The purpose of this video is to look at the claim made by TheMorgile that the planet Venus should not have been visible from Michigan on the evening of June 16th at around 11:30 p.m. So let's watch his video first, and then we'll address his claims. He doesn't bother telling us what that source is, but I'm not really going to pick an argument with him over this diagram. It occurs to me that you can't actually hear TheMorgile speaking. That's irritating. So let me describe TheMorgile's claim then instead of playing the video. So he has a photo taken from somebody in Michigan on the evening of June 16th, 2018, sometime after 11 p.m. This is the moon. This is Venus. And the claim that TheMorgile makes is that this should not be possible in the heliocentric model. So he creates a not very to scale diagram. Instead of actually using this diagram, he creates his own diagram, not to scale. And then he makes a lot of poor assumptions. So he creates the Earth here. So we have half the Earth in light, half the Earth in shadow. Then he says that this point here is midnight. And so he determines somewhere over here be 11 o'clock at night. Now, the first thing he's doing wrong here is going by these values of time, which, first of all, are very human ways of talking about things and not very astronomical ways of talking about things. He's ignoring the fact that Michigan is in daylight savings time. So for them, midnight is going to be 15 degrees 15 degrees clockwise from where you would normally call midnight. And so 11 o'clock would be 30 degrees clockwise of where you would normally call midnight. He also assumes that the observer is on the equator, on the very outside rim of this circle, not realizing that the observer could be anywhere on the circle. My diagram will show where the observer really was. So he goes on and he draws a line, he draws this tangent line, and he shows you how the tangent line can never intersect the orbit of Venus. Now, I don't know how accurate the spacing between these orbits is, but he's making a rather inaccurate diagram on purpose in order to advance his claim. He's also drawing this line in the wrong place and at the wrong angle. He then goes on to say, if we look at the time that Venus set, he says that in Illinois, Venus sets on the night of the 17th to the 18th, which is, again, a day later than we're looking, and it's not the right place. Venus sets at 11:05 p.m. Now, Illinois is to the west of Michigan. If we look at Michigan's value, which we will in a moment, we'll see that this value is not the correct value for Michigan. So he goes on to say how this image, which he doesn't actually provide a real location or a real time. He simply says it was taken after 11 p.m. on June 16th from Michigan. He doesn't say where in Michigan. But so he goes on to say that this debunks the heliocentric model because Venus shouldn't be visible. So let's look at some real data. I've chosen the location of Midland, Michigan. This is a rather middling part of the state. I didn't put it in the Upper Peninsula. I basically put it more or less halfway in the Lower Peninsula of Michigan. On the day in question, 16 June 2018, sunrise was at 5:54. Solar noon was at 13:37. That's 1:37 p.m. And sunset was at 21:20. Or 21:21. That's 9:21 p.m. And these are local times. And we can see that the local time is 4 hours behind UTC time. If we look at timeanddate.com for Lansing, Michigan, which is nearby, we can see that on the night of June 16th, 2018, Venus set at 11:51 p.m. If we create a diagram using the orrery at formulab.ch, we enter the date of June 17th at 3:30. This is UTC. So again, if we subtract 4 hours, we'll get 6:16 at 11:30 p.m. We show just the inner solar system, and we set the observing site to the coordinates of Midland, Michigan. Those will come in handy. Well, actually, we don't even need those here. But so this is a diagram of what the inner solar system looked like. Here's Earth, here's Venus, and here's the Sun at 11:30 p.m. local time in Midland, Michigan. Down here, we have the ephemeris, and we're most interested in the right ascension and declination and distance of the Sun and of Venus. We can use these pieces of information to create a 3D model of the Earth, the Sun, and Venus. And so I've done just that. This is a sphere. This sphere represents the Earth. I have 1 unit on this graph is equal to the radius of the Earth. So 1 unit is approximately 3,959 miles. I have 2 circles on this globe. The circle here represents the equator. And the circle here represents the latitude at which Midland, Michigan is. And we can verify that it is Midland, Michigan. We draw a line from the center of the sphere up to our observer up here. We can see that the angle it creates with the equator is always 43.615833 degrees. So this observer is at the latitude of Midland, Michigan. I have some other things on this diagram. First of all, these 2 strong dashed lines are lines to the Sun and to Venus. We're going to look at them overhead. So this is a line to the Sun. This is a line to Venus. And I have these additional dashed lines. These are the observer's lines to the Sun and to Venus. And we can do some interesting things with this graph. It's a 3D model. I'm going to bring the observer around. And we're going to see, let's turn on intersection points. Okay. So now we can see that gray dot represents where the observer's observation line to the Sun intersects the Earth itself. So as long as that gray dot exists, that means the Sun is not yet risen. We can find out exactly where the sunrise happens by waiting for that gray dot to disappear. So the gray dot has disappeared. So now we have a sunrise point. A sunrise point right there. Sunrise occurs. We can go around, find where sunset occurs. We can put another dot there. That's where sunset occurs. We can do a similar thing with Venus. We're not really interested in when Venus rises. We're interested in when Venus sets. So let's keep going around. Let's turn on the intersection point for Venus. There we go. So now we have an intersection point between the Earth and the line to Venus. And that represents the point at which Venus sets. Okay. Now, the trajectories of these lines, of these strong dashed lines, these lines were created using the ephemeris data here. The sun is at 5 hours, 42 minutes, and 10 seconds of right ascension, and 23 degrees and 22.3 minutes of declination. Now you'll notice this is awfully close to the tilt of the Earth, 23.4 degrees. And that's because June 16th is very, very close to the date of the summer solstice, when the northern hemisphere is completely tilted 23.4 degrees towards the sun. So both of these dashed lines were created using the ephemeris data. So they represent where the sun and the moon really appear from the center of the Earth. The dashed line, the dotted lines are simply created by creating a line from the observer to the sun and from the observer to Venus. So we know now that this 3D model accurately represents the location of Venus and the sun relative to the Earth at 11:30 p.m. on June 16th from Midland, Michigan. So let's see if it really is possible for the observer in Midland, Michigan to have seen Venus for as long as he did after sunset. Let's find out. When was sunset? Sunset was at 9:21 p.m. So we can say that this point here on our sphere represents 9:30 p.m. and 9:20 p.m. Okay, or 9:21 p.m. 9:21 p.m. And we know that Venus set right here at 11:51 p.m. So that's almost exactly 2.5 hours after the sun sets. Okay. So that would mean that there has to be 2.5 hours of rotation here between sunset and Venus set. So let's find out. What is the angle between this point and this point? We can do that very easily. We have the center of our circle at 43.615 degrees latitude. We can draw a line between sunset and the center, between sunrise and the center. We can get that angle. There is about 131.5 degrees between sunset and sunrise. So 360 minus 131.5 is 228.5. That's how many degrees the sun was in the sky, which is 0.63, which is 63% of a day, which is about 15.2 hours. Was the sun up for about 15.2 hours? Yes, it would appear the sun was up for about 15.2 hours. Okay, so we know that these points are accurate. Now let's look at the angle between sunset and Venus set. We'll just draw another line and determine that angle. And the angle there is 36 degrees. 36 degrees out of 360 is 1/10. Multiplying 1/10 by 24, we get 2.4 hours. 2.4 hours is very close to the 2.5 hours. So we can see that my points on this circle are very accurate. They might not be exact, but they are very accurate. They are very good approximations, which means that it was perfectly possible for an observer at 43.6 degrees latitude north to see Venus 2.5 hours after the sunset. And we know that 2.5 hours after sunset included 11:30 p.m. So the Morgile. Here is an actual, calculated, measured 3D representation of the Earth, the Sun, and Venus. And we can see that an observer at 43.61 degrees latitude should in fact have been able to see Venus for as long as Jason says he did. That's all I wanted to show with this video. If anybody watched, thanks for watching. This is why the heliocentric model works and the flat Earth model, which doesn't exist, doesn't work. Have a good rest of your day.